Welcome back to this new video. So far, we studied algorithms, conditionals, relational logic and operators, and multiple conditionals. In this video, we are going to study another structure that is very helpful, which is repetitions. Let's see this problem. Print the odd numbers that are greater than 10 and less than 1000. In this case, we are first trying to draft some ideas on how can we solve this problem, but we are not going to just start writing the pseudocode or the flow diagram. You will understand later on why we are doing it like this. So let's see some ideas. First, we need to have the values from 10 to 1000 in a variable, one at a time. So in this case, we cannot think on having 1000 variables. We just have to do it using only one variable and having a different value at a time. Once we have that values on the variable, then it is simple because it's similar to the previous algorithms that we already solved. So if we have the number, we just use a conditional to ask if the number is odd. In the case that the condition is true, then we just print the number. So that two last steps, we already know how to do it. So let's see in a pseudocode, how can we do that? So say first we assign the value 10 to the variable number. Then we increment the number in 1, because if you see the problem, it says that they are greater than 10. So 10 is not greater than 10. So we must make sure that the first value that we analyze is 11. So now the conditional. If the number, the remainder of the division of the number by 2 is equal to 1, then the number is odd. Then we print the number. So after that, now we are going to use another condition, but this one is in a different way. If you see, if the number is less than 1000, then we are going to go to the step 2. So we didn't see these type of examples before. And if we go to the step 2 from step 4, then step 3 will be repeated. And that's why we call this type of algorithm with repetitions. So notice that if the initial value of the number is 10 and we increment 1 every time, the variable number, eventually the condition of step 4 will not be true and the algorithm will finish. So first number is 10, then we increment number in 1, then it will be 11. So when in step 4, when we go again to step 2, we increment the number in 1 again, and then it will be 12. And so on, then it will be 14 and 15 until it is 1000. So in that case, when it's 1000, the step 4, the condition will be false and the algorithm will finish. This assures us that the algorithm is finite. One of the characteristics that every algorithm needs to have. If the algorithm is not finite, then it will never finish. You will never have a solution to the problem. Let's see how this will look now in a flow diagram. So we first start and we say number is equal 11. After that initial value, then we check a condition. If number is less than 1000, if it's false, we finish. But if it's true, then we ask another condition. We state the conditional if the remainder of the division by 2 is equal to 1, meaning the number is odd. If that condition is true, then we print the number, and we increase number in 1. After we increase the value of the variable number, we check again if the number is still less than 1000, and we repeat the whole process. As you can see, if it's true, we will repeat all the instructions to check whether the number is odd or not, but if it's false, then we just finish. So in programming, we call this type of structures loops. And then we have two types of loops. Loop with precondition, like in the example, while condition, do block of instructions, and then we finish. So what the precondition means is that if the condition doesn't hold at the beginning, the block of instruction will not be executed. And then we have another type of loop, that is loop with postcondition, that have the structure repeat, do block of instruction, while condition. As you can see, the block of instruction will be always executed at least one time. And after the first time that is executed, then we check if the condition holds or not. That's why it is called post condition. So let's see now how the algorithm will look using the while loop structure. So in the left side, we have the first solution that we give to our problem, which is we use the go to step 2. So go to is kind of an old structure that we don't use anymore in programming, but it is still a valid structure to design an algorithm, to create an algorithm. So in the right side, we use while. In this example, you can see in line 5, we don't have to state a go to line 2. The end while structure just give us that functionality. We don't have to state go to when the compiler arrives to that line. Then it will automatically go to the line where the while is supposed to start. It will check if the condition holds, and if it holds, we'll execute the block of instructions again. So this one is kind of a simplified version of the previous solutions that we created. We also have another type of loop, is a for loop. In this loop is a precondition loop. So it first checks if the condition holds before it executes the block of instruction. But this structure allows us to give an initial value to a certain variable, to state the condition, and to state the increment in just one line. As you can see on the left side, that's the way that we specify it. So we say for variable equal to initial value, then we have the condition that we want to check all the time before we execute the block of instruction, and we also have the increment. The increment is usually 1, but you can have as increment anything that you want. You just need to make sure that with the increment, it will eventually, the condition won't hold, so the for loop will stop. In the right side, you can see the example of solving our previous problem with the for loop. So in this case, we just state for number equal 11, number less than 1000, that is the condition that we are going to check every time, and number plus plus is the same that number equal to number plus 1, or the same that increment number in 1. Then within the for loop, we just need to ask if the number is odd, we print it, and then we state when the for loop is finishing. we say in line 3 and 4, that just tells us that in that line is where the for loop finish. We don't have to, as the same like in the while, we don't have to write a go to certain step. We just have to show that that is the end of the for, and then the for structure will take care of the loop for us, of the jump to the where the for loop starts. So let's now see both solutions, the while loop and the for loop. As you can see, in the while loop, we need to initialize the variable before the while. That type of variable that we use to control how many loops, how many iterations the loop will have, we call it a control variable. In the case of the while, the control variable needs to be initialized before the line of the while. And within the while, we need to modify that variable so we make sure that the while will finish eventually. In the case of the for, the control variable is declared and initialized in the same line than the for loop. It also the condition, it is on the same line, and the increment is also in the same line. So that is basically the two main loop structures that we have, which is in this case for precondition loops, we have the while and the for, while loop and for loop. You can use both of them, as you can see. It depends mostly on what you prefer, but with both you can do exactly the same. You can also use a different way of defining what is within the loops. You don't need to always use n for or n while. You can use another structure that is the one that is commonly used in programming languages. As you can see here, we are using brackets to define where the block of instructions for the loop start, which is at the end of line 2, and where it ends, which is in line 5. As you can see, I just changed the n4 for the closing bracket and the n while for the closing bracket, and then I add the opening bracket on the line where the while is and the line where the for is. So you can still use n for or n while. It is just another way to do it. I think that is simpler because you have to write less. So for me, whatever solution is simpler, that's the one I want to have. So let's see another example. Let's print the sum of the odd numbers that are greater than 10 and less than 1000. As you see here, we are not just printing the numbers that are odd. We are printing the sum of all the numbers that are odd. So in this case, because we have to go through all the numbers from 11 to 1000, we also have to use a for loop. We just need to have a variable that we will use to sum all those numbers that holds the condition. In this case, our first step is to initialize that variable in 0, because 0 is the neutral for the sum. So whatever we sum, we need to make sure that doesn't modify our previous number. Say, for instance, if the first number is 1 and the second one is 2, then the sum must be 3. Because it's initialized in 0, then when you sum 0 plus 1, you will have 1, and then when you sum 1 plus 2, you will have 3. So the 0 doesn't make a difference on the sum of all the numbers. That is why we have to initialize it in 0. If it is initialized in any other number, then the result will be wrong. So then we are going to use a for loop. As we saw before, we initialize number at 11, then the condition is number less than 1000, and the increment will be in 1. Then we use a conditional to determine whether the number is odd or not. If it's odd, then we add it to sum, to the variable sum. And when we finish the for loop, we just print the sum. So in this example, if you see in the conditional, I added the word then to the condition. I did this just to show you that sometimes you can modify the way that you show your pseudocode in any way that makes it easier for you to understand. So with the then it just sounds better when you read it. It sounds more like English, but you can do it in any way you want. I just did it here to show you that pseudocode is not a formal language. It doesn't have strict rules. You can use your own words. You can slightly modify some structures. You just need to make sure that other people can understand it easily. In this case, the word then doesn't change anything. As you can see, the meaning of that conditional is still the same. So feel free to use your own conventions. Just make sure that people understand your own conventions when they read it. As a summary, in this video, we saw how useful can loops be when we are solving certain type of problems. Just imagine that instead of those 3 lines that we use in the for loop, we need to have 1,000 variables. That is not practical. We cannot solve problems in that way. So when we need to repeat certain things many times, then we need to use loops as a way of solving the problems. Then we have 2 types of loops. We also must be very aware of this. We have loops with precondition and postconditions. We use preconditions when we need our block of instructions to be executed only if the condition is met. And we use postcondition when we want our block of instructions to be executed at least one time, and then if the condition is met, then it can repeat again the block of instruction. If not, then we finish with that block of instructions. By using loops, we can solve more complex problems, and it is really a wide variety of problems that we can solve by using loops. Thanks for watching. I'll see you on the next video.